Now we need to find the absolute maximum moment for this simply supported beam subjected to series of concentrated load as seen in here. To do that, for the first step, we need to determine center of gravity for series of point load as shown above. To do that, we need to take a reference point at wheel number 1. Then we need to sum up all the forces. Then we're going to find where is the resultant force. The total of resultant force is 5 plus 20 plus 20 plus 15 and plus another 15 kilonewton. We don't know where is this resultant force will be, so we name that distance as x bar equal to 20 times by 1. As I told earlier, we take this point at wheel number 1 as a reference point. Therefore, 20 times by 1 meter for the second wheel. Then for the third one, 20 times by 2 meter. Then plus another 15, and distance for that is 1 plus 1 plus 1, so 3 meter. And plus the last load from wheel number 5, where it 15 times by 1 plus 1 plus 1 plus another 1, so 4 meter. Then we can find where is the distance of our resultant force. So we get our x bar is 165 divided by 75. We get 2.2 meter. Therefore, we can locate our resultant force. So this is our R, 2.2 meter from our reference point as I told earlier at wheel number 1. So this is 2.2 meter. For the second step, the maximum moment gonna occur at wheel number 3 or number 4 because our resultant in between wheel number 3 and number 4. So we take for wheel number 3 first. So we have to find where is the x distance. By using the formula, the total length divided by 2 minus a divided by 2, where our a is 2.2 minus by 2 meter. So we get our a is 0.2. Once again, we have our x bar is 2.2 and distance from wheel 1 to wheel 3 is 2 meter. So minus by that 2 meter, we get our a is 0.2. Then we can calculate our a is 4.9 meter. Therefore, we identify the distance for that is here. So the balance of the distance is 10 minus by 4.9, we get 5.1 meter. Then we need to draw influence line for this case. So we can use the formula AB divided by L. So we get the highest point is 2.499. Then we have series of concentrated load from these 5 different wheels at respective distance, as we can see here, 1 meter from one another. Because we know the highest value, that means we can interpolate easily to find another value at here, here, here and here. So by using the interpolation, we get our value on our influence line: 2.009, 1.519, 1.989 and 1.479. Then we can find moment for the first case. So on wheel number 1, the force is 5 kilonewton. Therefore 5 times by 1.479. Then plus 20 on the second wheel, 20. The value on our influence line is 1.989. Then plus another 20 kilonewton on the third wheel. Value for that is the highest, 2.499. Then plus load from 15. Value for that on influence line is 2.009. Then plus another one, the last load 15 kilonewton. The value on the influence line is 1.519. So we get our value for M1 is 150.075 kilonewton meter. Next, say the maximum gonna occur at load 4. So we're going to use this formula, X equal to L divided by 2 minus A divided by 2. So this is wheel 3 and wheel 4, and our resultant in between at distance of 0.2 and 0.8. Because wheel number 4 on the right side, so it will be negative, because this rotation to the right is negative from R, so R to 3 is positive. So our A is negative 0.8 meter. So substitute A in our X, so we get our X value is 5.4 meter. Therefore here is 5.4 meter, and balance of that is 10 minus 5.4, we get 4.6. Then we need to draw our influence line. We apply internal hinge at here, allow rotation, so we get our influence line. So the maximum value for that is 2.484, and it's subjected to our 5 wheel with respective load. We know the highest value here is 2.484. Simply we can interpolate to find another value here, 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 and here. So by do the interpolation, we get those value where on 5 is 1.104, for 20 kilonewton 1.564, for 20 is 2.024, and for 15 kilonewton is 1.944. So we can calculate our M2. So for our M2, 5 times 1.104. Then for 20 kilonewton, 1.564. Then for next 2 kilonewton is 2.024 plus 15 kilonewton times 2.484, and the last one for 15 kilonewton is 1.944. So we get our M2 is 143.7 kilonewton meter. Therefore, compare between M1 and M2, we know the maximum moment occurred at 4.9 meter from left, which is for the case M1, where the moment is 150.05 kilonewton meter.